Let's look at this generic problem using Desmos. And so we want to complete this table. So we go to Desmos and g of x equals, because I'm using x again as my input, 5 parentheses x minus 11. We don't care what the graph looks like right now. We just want to create the table. So I'm going to go to the gear, convert to table, and I'm going to change these values to match my input values that I have here. So negative 4.6 and so on and so forth. We have 12.8 and 20. And so now we can fill in those table with those values that you have there. And then in part A, kind of maybe part B, but part A, it says solve algebraically. So again, solve means that I know the output value, and so my output value is -2. And so I know that I have -2, and that equals the rest of my equation there. So that equals 5 times the quantity p minus 11. And so I want to solve this algebraically. And so the p minus 11 is in parentheses, so I'm going to ignore that first. We have multiplication here, so I'm going to divide by 5. When I divide by 5, I get negative 0.4, and that equals p minus 11. And now that I have p minus 11, I'm going to add 11. And when I add 11, I end up with my input value of p, which is 10.6. Okay, so in line 1, we have our, we're going to, use Desmos to find that same answer or using the graph. So line 1, we have the equation. In line 2, I guess I have my table, so I'm going to say line 3 in this case. If you get rid of your table, by all means, you can say line 2, but whatever line we're working with is the one that we want to indicate. So line 3 in this case is going to say y equals -2. And so when I type in y equals -2, I can barely see, so here's my y equals -2 line. I barely see my graph over here, so I can go ahead and move this move my graph over, and I can click on where that intersects, and sure enough, I'm going to get the same input value that I found algebraically. And so I know that the input is 10.6, and the output is -2. That's writing it as an ordered pair. If we wrote it in function notation, we would say g of the input that we found, 10.6, and then that equals the output of -2. So one more look at how would we graph this by hand. So that's what we could do in terms of which values would you use to display an appropriate graph showing the point of intersection. Because over here we just moved our graph around. But let's think about what is, if I were to graph these ordered pairs, I would need to go in the input. So again, here are my input values. My input values are from -4.6 to 20. So maybe I want to go from -10 to 30 and count by fives. So if that's what we want to do, if we were to do that by hand, so we would go from -10, we go to 30, and we're going to count by fives. And then for the outputs, if we look over here, our smallest output is -78. And then our greatest output looks to be 45. And so maybe we want to go from -100 to 50 or 60, and then count by maybe 25s. So again, in our little key down here, so we'd go from negative 100 to 60, and we're going to count by 25. So we want to see that rather than necessarily always playing around with our graph, although we can. But this is just practice to think about how would I hand draw this and how would I scale that hand drawing, and if I did, there so that I can find this intersection. So again, go to the wrench, which indicates graph settings, and we're going to change our values to match what we wrote down. So negative 10. We're going to go all the way up to 30. We're going to count by fives. And for the outputs, the vertical axes, we're going to go from negative 100 up to 60 and count that by 25. And when I click off, I should easily see my intersection point there. Notice when I clicked on the graph, I could find my horizontal intercept. It also gives me my vertical intercept if I were looking for my vertical intercept as well. But right now I'm looking for where the line intersects, where the y equals -2 line intersects to find me my my input value.